All right, last little bit to this first huge lesson. You will find that not much difference here. Look, this is a panic and a phantoms. And so we'll just talk about the little differences. So here we go. So this is Andre, who's a waiter in San Francisco, and he is being accused of underrepresenting his wages or his tips, and so he's not paying enough to the IRS. So what they do is they get, in an effort to satisfy the IRS, Andre took a sample of 8 credit card receipts, which each had the tip. And so the sample mean of those 8 was 1235 with a standard deviation of 225. Okay. So we're going to first start off today that all the conditions for inference have been met, because hopefully the fact that it said a sample size of 8 is a little alarming to you, because that is a small sample size, and we need to address that. And we will address the conditions for the inference tomorrow. But anyway, this first thing says find a 90% confidence interval to estimate the average of all of his tips. Okay, so let's take one sample and estimate his average of all of his tips. So look here. So in the panic model, the first one is parameter. It is not a proportion anymore. It is a mu, and I put a little t for the tips. The mu of the little t's equals the average. So this first word is not proportion. The average of all Andre's tips. The assumptions and conditions have been stated to be met, so that's not an issue. And here's what this is called. A, one sample, because later we'll have a two sample. It is a T interval, not a Z interval, for means. So there's one sample. It's a T interval for means. And why is it T? Because we're having to use a sample's standard deviation. So I wrote all of this information over here, and I did notice that I listed the sample size, the degrees of freedom. I just wrote myself some notes over here. The X bar was 1235. Now the sample standard deviation, so just the little s of x, was 225. So the sampling distribution, the x bars standard deviation, was that 225 over the square root of n. And that came out to be 0.80. I think it was like 0.795 or something. Now, 90% confidence. So that's T critical value we're going to have to use is that inverse T with 90% in the middle puts our 0.05 comma 7 degrees of freedom. Now, I really should have, and so I'm going to even type it in here. When you do this, must include the DF. I mean, you probably would get credit for it being over here, but I just don't want that DF, the degrees of freedom, to be a little side thought. No, your numbers are based off of that degrees of freedom. So it has to be prevalent. I mean, it's important to notate that. Okay, so we're doing these by hand back again because it's just one, and I got to keep you being able to do that. So let's remember that our intervals are made from that statistic, that sample mean. So the sample mean was 1235. And then here was the critical value, plus or minus that critical value. And so that's what we had over here with our little 1 point, or our inverse t of 0.05 with 7 degrees of freedom. Okay, so, and then our s of x over the square root of n. So here is how I'm going to do the math. I'm going to do the 1235 plus this margin of error and 1235 minus this margin of error. And then the result is over here. So the estimate for the mean is from 1084 to 1386 with 7 degrees of freedom. Okay? All right, so I am 90% confident that the true average of Andre's tips is between 1084 and 1386. Well, now we're asked to test the claim that IRS makes that Andre makes more than $10 per tip on average. Now, before we even go into it, what do you expect to happen? looking at this interval, now we are not allowed to state we have evidence or not evidence and like run a hypothesis test just based off an interval. Okay. But what do you anticipate happening since $10 is not in this interval? What do you think is going to happen? Are we going to have evidence to reject $10 or are we going to fail to reject $10? I hope you can see you're probably going to reject $10 and say that you have evidence that it is that his average tip is more than $10. Okay, the average of his tip. So we have the same phantoms, or the same parameter. The mu of t is the average of all under his tips. HO is the mu is $10. HA is that the mu of his tips is greater than $10. The assumptions have been met. Here's what it's called. A one sample, because we're going to do 2 in a couple of days, t-test, not t-interval, for means. Okay, and then I wrote all that, there's that information, which we already had. But see, look at what's happening. Here's our hypothesized value. We're seeing how far is the sample results away from what we are hypothesizing them to be in terms of that standard deviation. So to get my p-value, because we were wanting to go greater than 10, we TCDF from that 2.94 to 99 or 999, whichever, just a bunch, with 7 degrees of freedom. Must include the DF. So make sure we have that DF is known. We used the curve number 7. So that p-value was pretty small. Well, what does that mean? If our p-value is small, if our p-value is low, we're going to reject HO. Since that p-value is less than alpha, I reject HO, and I have evidence. So p-value is the only way that we can reject HO, not with an interval, okay? Interval can support our decision, but you are not supposed to make a statistical claim from an interval. There is evidence that the true average of all Andre's tips is greater than $10. Okay, so there it is, the phantoms and the panic, and then you're going to go on to the assignment. All right, but there it is all together in context. And once we've all done the ideas, now putting it together is pretty straightforward and like what we have done in the past. All right, so good luck to you on your assignment number 1.